differentiability of inverse functions. And so first of all, if we look, it just says let f be a function whose domain is an interval I. Okay, if f has an inverse function, then the following statements are true. If f is continuous on its domain, then the inverse is continuous on its domain. So, what it basically means is that there's a relationship between the two. If f is increasing on its domain, then the inverse is increasing on its domain. If f is decreasing, then the inverse is decreasing. And if f is differentiable at c, and the derivative does not equal 0, then the inverse is differentiable at c. Okay, so it basically means that they're buddies. Okay, the characteristics of one are pretty much the characteristics of the other. And so the derivative of an inverse function says let f be a function that is differentiable on an interval. If f has an inverse function g, then g is differentiable at any x for which the derivative of the inverse does not equal 0. Okay, and well, I don't think you maybe need to write that down. We're going to look at an example. Okay, this right here is the inverse. Okay, that right there is the inverse. That's what g is said to be. So basically, when it says g prime x, that means the derivative of the inverse. Okay, and that's kind of confusing because we're used to seeing g as the second function. Okay, but what they're saying is that if you want the derivative of the inverse, that will equal 1 divided by the derivative of the original function at the value of that inverse. Okay. Alrighty, so let's go ahead and look at an example. You will need your calculators handy. Okay. Now, it says let f of x equal 1/4 x cubed plus x minus 1. Now, these are like the last two problems on your homework. Okay, it says what is the value of f inverse of x when x equals 3? So essentially, what they are wanting you to find is the value of the inverse at 3. So now we need to think back to what we just talked about with graphs. Okay? We need to think back to over here, what I have written here on the board. I know those of you on the video, you can't see the board, but that's okay. All right? And so what they're telling you is they're saying, okay, what is the value of f inverse when x equals 3? So basically, it would be similar to what I have here. Okay, what I want to do is I want to find this x value right here. Okay, because it would be like these two are the 3's. The zeros are the 3's. So I need to find that x value where the function is 3. Okay. So let's go ahead and graph that. That's the easiest way. So go ahead and type that in on your calculator. What I would do if I were typing it in is I would use 0.25 x cubed plus x minus 1.
Is the, you have a parentheses on the second f, is it the same thing though?
B?
Yeah.
We'll talk about that in a little bit, okay? So basically what I want to do is I want to find out where the original function equals 3. I want to find that x value, okay? So there's two ways to do that. One, you can trace and get close to what you think the answer is and see if the value works. Or two, we can do an intersection. What do you want to do?
Trace.
Okay.
Where do we go to trace it? So
Hit the
X3?
trace button. If you just hit the trace button and then use your left and right arrow key. Now we're looking for where y equals 3 in the original function. Where does y equal 3 in the original function?
8.5, or about 9.
I don't know why.
What?
2, alright, but,
Where y equals 3 in the original function.
oh.
2.
2.
2.
So basically, what that is saying is that on the original function, I have a point 2, 3. Okay? That's a point on the original function. So the inverse of 3 will be 2. Okay? So you see how that worked? It's kind of the flip. Now on this next one, why you were asking about parentheses, it wants to know what is the value of the inverse's derivative when x equals 3. The inverse's derivative when x equals 3. So this is like the previous slide. Okay? This is like the previous slide. And the previous slide at that very last statement, and in fact we can go back and look at that, says, here's the derivative of the inverse. That's going to equal 1 divided by f prime at that value. Okay? So what that means is that means I'm going to take 1 divided by f prime at what?
3.
3. Okay? No. It's the other value. It's 2. It's not 3 because it says g of x.
Which is,
Okay? So then now, let's go ahead and find the derivative of f prime of x. The derivative will be what?
3, 4, 6 squared plus 1.
Okay? So now, I'm going to plug in 2. So 3/4 of 2 squared plus 1 will be what?
4.
4. So your answer is 1/4. Okay? You've got 2 problems like that. Biggest thing you need to get, and this is kind of hard, I'll be honest with you, it is hard to master. This is your pair, this is your pair. Those will match. And basically what they'll be is they'll be the reverse of the original point. So if the original point was like 1/4, so if the original point here was like 1/4, these numbers here would be 4, 1, 4, 1. Okay, so it's just basically the flip of the ordered pair. Okay, you only have 2 of those to worry about. That was 71 and 72 at the very end. Okay, so we need to go ahead and finish this. You're going to have a short quiz tomorrow. The quiz tomorrow will be over integration of the natural log function, section 5.2, and it'll have about 1, maybe 2 problems from this section. Okay?